Good day, learners. Welcome to our physical sciences lesson. My name is Amenim Kize. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with the Gauteng Department of Education. Right, grade 11 learners. Today we are going to focus on knowledge area chemical change, and then the topic under chemical change, it will be quantitative aspects of chemical change. So this topic, I hope you know very well that is across all grades. You did quantitative aspects of chemical change in grade 10. You will also be doing quantitative aspects in grade 11. And again, in grade 12, remember this topic is also examinable in that grade. Okay, so when it comes to quantitative aspects of chemical change, so according to our examination guidelines, this is what we need to focus on, right? Atomic mass and the mole concept. So describe the mole as the SI unit for the amount of a substance. Define 1 mole, define relative atomic mass, describe Avogadro's number, define molar mass, describe the relationship between molar mass and the relative molecular mass, and also the relative formula mass. All right. Calculate the molar mass of a substance, giving its formula. Calculate the mass, the molar mass, the number of moles according to the relationship using the equation N equals to M over capital letter M, where M is mass of a substance in grams, and then capital letter M is the molar mass in grams per mole. Determine the empirical formula for a given substance from percentage composition. Define empirical formula. Define molar mass, define what molar mass, determine the number of moles of water of crystallization, define water of crystallization, determine the composition of substances or the percentage word composition, find the percentage composition of a certain substance, define the concentration. This is according to our examination guideline. Actually, it's what we need to cover under this topic, quantitative aspects of what? Of chemical change. Then calculate the concentration using the equation C equals to N over V, state Avogadro's law, interpret the balance equations in terms of volume relationships for gases, right? And also we will be focusing on the basic stoichiometric calculations, determine the theoretical yield, determine the percentage yield, the percentage purity, find the limiting reactant, and also after finding the limiting reactant, perform what basic stoichiometric calculations. So it's what we need to focus on under quantitative aspects of chemical change. So this is according to our ATP, or it's according to our examination guidelines. So this is what we need to cover. So what is important? So this topic is important for all the grades, grade 10, grade 11, and what? And grade 12. So I'm not going to say I'm focusing only on the grade 11s, right? Even the grade 10s, this topic is very, very important for you. And at this moment, grade 10, we are busy with quantitative aspects of chemical change, right? Even your grade 11s, this term, we are busy with, quantitative aspects of what? Of chemical change. Same with the grade 12s, right? For your paper 2, okay? So, our basic stoichiometric calculations, they are there in all the topics. When it comes to your organic molecules, you'll find a question where they will say determine the empirical formula or the molecular formula, right? When it comes to reaction rates, you'll also be performing, basic stoichiometric calculations there. Even when it comes to chemical equilibrium, right? Your acids and bases, there are basic stoichiometric calculations there. Your electrochemistry, there are also basic stoichiometric calculations there. Hence, I said to you, this topic is very, very important for all grades, grade 10, grade 11, and also what? Grade 12. Right. So let's start. Let's start with the atomic mass and the mole concept. Okay. This is what you did in grade 10. All right. The definition of what? Of 1 mole and the molar mass. All right. So 1 mole of a substance is defined as the amount of a substance having the same number of particles as their atoms in 12 grams of what? Of carbon 12. So this is how we have to define what 1 mole of a substance. And again, a mole, we should know that is the SI unit for the amount of what? Of a substance, all right? And then the molar mass, what is molar mass? The molar mass is defined as the mass of 1 mole of a substance that is measured in what? In grams per mole. So if you are asked to calculate molar mass, right? So let's not forget the SI unit. So the SI unit is grams per what? Per mole. So this is these are the basics. Actually, this is what you did in what? In grade 10. So you must be able to define 1 mole of a substance, right? And also know that mole is the SI unit of the amount of a substance. And what is the molar mass? The molar mass is the mass of 1 mole of a substance that is measured in what? In grams per what? Per mole. Right. Then the relationship between what mole and the Avogadro's number, right? So the Avogadro's number, the symbol for the Avogadro's number, right? It's Na, right? So Na, we should know that that is the Avogadro's what? Avogadro's number. Okay, and what is the value of the Avogadro's number? It is 6.023 times 10 to the power 23 watt per mole, right? And what you need to know, so here we are focusing on what? On the relationship between what? Mole and Avogadro's number. So from grade 10, you already know that 1 mole of a substance, so 1 mole of a substance is equals to Avogadro's constant or Avogadro's number, which is 6.023 times 10 to the power what? To the power 23 per mole. All right. So that is the relationship between what? The mole and the Avogadro's number. So 1 mole of a substance is equals to 6.023 times 10 to the power what? To the power 23. So that is the relationship between what? The mole and the Avogadro's number. 1 mole of a substance is equals to 6.023 times 10 to the power what? 23. All right. Then the relationship between amount of a substance, right? Relative atomic mass, molar mass, and the relative molecular mass and the relative formula mass. All right. So these are some of the things that you'll be asked, to calculate. Okay. So the question can say calculate the molar mass, right? By now you know what is the molar mass, right? So that is 1 mole of what? Of a substance. That is what a mass of 1 mole of a substance that is measured in what? In grams per mole. All right. So you'll be asked to calculate, the molar mass, the relative atomic mass, the relative molecular mass, and the relative formula mass, right? So what is common when it comes to calculating the relative atomic mass, molar mass, relative molecular mass, and the relative formula mass, right? So one, for you to be able to calculate, the molar mass, formula mass of a substance, right? You need a periodic what? Table, right? That is the important tool that you need for you to be able to calculate a molar mass of a certain substance. All right. So you'll be able to calculate the molar mass, the relative atomic mass of of a substance if you are given its molecular formula. All right. If you are given its molecular formula, then you'll be able to calculate what its atomic mass or relative atomic mass, the molar mass, the molecular mass, and the formula mass. Right. And another thing that you need is your periodic your periodic table, right? So I have the periodic table here. This is the periodic table, right? So it's what you need for you to be able to calculate the molar mass of a substance, to calculate the relative atomic mass, relative formula mass, relative molecular mass. All right. Then again, calculating the mass, the molar mass, and the number of moles, right? So the equation that we can use to calculate the mass, right, the molar mass, and the number of moles. We can use this equation. The equation is N equals to mass divided by by molar mass, right? So what is important here, learners, is to know how to calculate the molar mass, right? Maybe before that, know what is molar mass, right? So the definition of the molar mass and how to calculate the molar mass. I said to you, you'll be able to calculate the molar mass of a substance if you are given its molecular formula, right? So if you are given its molecular formula and you have the periodic table, then you will be able to calculate the molar mass of a substance, right? Then again, you can also calculate the molar mass of a substance if you know the number of moles of that substance, and also if you know what the mass of what of that substance, then you'll be able to calculate what the molar mass. So these are two ways in which we can calculate the molar mass of a substance. But the first one, you know, I think that is what we are used to, right? So in grade 10. So the first one, if you're given its molecular formula, right, use the periodic table to calculate its molar mass or relative what atomic mass, all right? Or if you're given the number of moles and the mass of that, you know, substance, then you can also calculate what its molar mass, all right? Then again, coming to this equation. So these are the equations, right, that you can use to calculate what the number of moles of what of a substance, right? Already I've talked to this one, right, that to calculate the molar mass, right, if you're given the number of moles and the mass of that substance, you can get what the molar mass, right? But in this equation, you can see there are three physical quantities there, all right? There is number of moles, there's mass, there's molar mass. So which means that you can use this equation to calculate what the number of moles of a substance given its mass and its molecular formula, all right? So its molecular formula, and then calculating from there, calculating its what molar mass, all right? Then you can also calculate the mass of a substance given the number of moles of that substance and the molar mass of that substance, all right? So by now we know how to calculate the molar mass. If you're given the molecular formula, then use the periodic table, you know, to calculate the molar mass of that substance, right? So this is N, which is the number of moles, and then the SI unit for number of moles is mole, which is MOL. That is the SI unit for what? For N, or for the number of what? Of moles. Right, then M is the mass of a substance, right? In paper 1, mass is the SI unit for mass is kilograms, right? That is paper 1, right? But when it comes to paper 2, which is chemistry, and then mass is measured in what? In grams, right? So in cases where you are given mass in kilograms, so you have to make sure that you convert those kilograms to what? To grams. So because when it comes to this equation, we need mass in grams, right? Then M there is the molar mass of a substance. We have talked about that, how we calculate molar mass of a substance, and then the molar mass of a substance is given by what? Or the SI unit for molar mass is grams per what? Per mole. So where is this grams per mole coming from? Remember N, it's in mole. And then M, it's in what? Is in grams, right? So if you can make what M here, which is the molar mass, the subject of the formula, you will have what? Mass over what? Over number of what? Of moles. Where mass is in grams, and then this one is in what? In mole. Hence, you will have what? Grams per what? Grams per what? Per mole. That is the SI unit for what? For what? For the molar mass, all right? Then this is another equation that we can use to calculate what the number of moles, right? So the number of moles, you have N equals to what? N over what? Over Na. So N, it's the number of particles, right? Remember, particles, it can be atoms, right? It can be molecules, it can be ions, it can be formula units, all right? So if the equation says calculate the number of particles, right? So particles, that is N. So you can use this equation to calculate the number of particles. Or if a question can say calculate the number of atoms, the number of molecules, the number of ions, the number of formula units, right? So those are number of particles, and the equation that we are supposed to use is N equals to capital letter N over Na, where N is the number of moles in mole, and then N is the number of particles, and Na is Avogadro's what? Number of Avogadro's what? Constant, which is 6.023 times 10 to the power what? 23, all right? So these are the equations that you can use, you know, to calculate what is the number of moles. So, or these are the equations that shows what the relationship between what? Moles, mass, and what? And the molar mass, all right? So we are going to use these equations to calculate number of moles, the mass of a substance, molar mass of a substance, you know, number of particles. So these are the equations that you can use to calculate that, right? So, but maybe before we use these equations, let's start with the molar mass. All right. So how do we calculate the molar mass? You know, given what the molecular formula, right? So the equations again, maybe before we do that, the equations again, there's no need for you to memorize them, all right? They are there on your data sheet, right? And again, there's no need to memorize the whole, periodic table. It is there on your on your data sheet, right? So these are the important documents that you need when you are dealing with stoichiometric calculations or quantitative aspects of chemical change, or calculations on quantitative aspects of chemical change. So the equation, I've already talked to this equation. Equation. This is number of particles, which is atoms, molecules, formula units, or ions, right? And then I've talked to that. So we are going to use these equations to calculate what the number of moles, mass, and the molar mass, and also the number of particles. We'll look into these other equations moving forward because it's what we are going to deal with today. All right. Then this is the periodic table. Then here we are still on the relationship between moles, molar mass, and moles, molar mass, and the mass, right? So again here, this equation, we can use it to calculate the number of moles, and then this one, we can also use it to calculate the number of moles given the number of of particles, right? Already I've talked to that, okay? So, but before maybe we use these equations to calculate the number of moles, let's start with, calculating the molar mass, all right? Calculating the molar mass, the relative, atomic mass, the relative formula mass, and the relative molecular relative formula mass, right? So when it comes to your periodic table, so let's go back. This is a periodic table. So when it comes to your periodic table, which is what I think you did in grade in grade 10, right? What are we having here? In each and every block, right, you have something like this, okay? For example, here they've used copper as an example. So you have the symbol of an element, all right? So for example, here it's Cu, right? That is the symbol of copper, all right? So, and then there's this number up there, right? That 29 there, okay? What is that 29? That is the atomic number. So the atomic number, that is the number of protons, right? In the nucleus of an atom, all right? So that is the number of protons. We have the atomic number there, right? And then the number at the bottom, for example, this 63.5, right? So the 63.5 is the relative atomic mass, okay? The 63.5 is the relative atomic mass, right? So where do we get the relative atomic mass? From the periodic table, okay? So we get the relative atomic mass from the periodic table. And we can see it has no units. So the relative atomic mass has no units, all right? For example, if a question can say, what is the relative atomic mass of chlorine, right? The relative atomic mass of chlorine, there's no need for you to think about it or to use a calculator or something. It is there on your periodic table. So the relative atomic mass of chlorine, this is 35.5. What is the relative atomic mass of boron, right? So as long as you know the symbol for boron, that it's B, then what is the relative atomic mass of boron? It's 11, right? What is the relative atomic mass of carbon? What is the symbol for carbon? It's C. So what is the relative atomic mass of carbon? It's 12. So you'll get your relative atomic mass of an element or of a substance from from the periodic table, okay? So for atoms, right, they are there, right? The relative atomic mass of those atoms, they are there on your periodic table. The relative atomic mass of lithium, it's 7, right? Relative atomic mass of beryllium, it's it's 9. Magnesium is 24. So you get the relative atomic mass from from the periodic table, right? Then what is the relationship now between the relative atomic mass and the molar mass, right? The relative atomic mass and and the molar mass. So the relative atomic mass, these are we get those values from from the periodic table, okay? So then what is the relationship between the relative atomic mass and the molar mass, right? So For example, we said the relative atomic mass of copper is 63.5. Then what will be the molar mass of copper? The molar mass, remember what is molar mass? It's mass of 1 mole of a substance that is measured in what? In grams per watt per mole. So it will be what? For copper, so the molar mass M for copper will be what? 63.5 grams per watt per mole. That is the molar mass, okay? So what is the difference? The value is the same between the relative atomic mass and what? And the molar mass. The value is the same, but what is different is that when it comes to your relative atomic mass, there are no units, right? And then when it comes to your what? Your molar mass, it is measured in what? In grams per mole. So the value is the same, but the difference is what? Is the units, right? So no units for relative atomic mass, and then there are units for what? For the molar mass, right? Same with the relative molecular mass, right? So if you say relative molecular mass, it's for molecules, right? Okay, so relative molecular mass is for what? Is for molecules, okay? Again, no units, all right? For the relative for relative molecular mass, and also the relative formula mass. So then there are no units, but those values we get them from what? From the periodic table. So the difference between your relative atomic mass, relative molecular mass, and the relative formula mass, right? And also your molar mass. Relative atomic mass, relative formula mass, and relative molecular mass. No units, right? But the values are the same, right? So, but when it comes to your molar mass, there are units, and the units is grams per watt, is grams per mole. So I think, learners, that is making sense, all right? So the values are the same, right? But the difference is that relative atomic mass, relative, formula mass, right? And the relative molecular mass, right, has no units. And then when it comes to the molar mass, there are units, which is grams per watt per mole, right? So the molar mass of copper is the relative atomic mass, right, of copper. Relative atomic mass of copper is 63.5 without units, right? But what about the molar mass of copper? Is 63.5 grams per watt per mole. So we can't say relative molecular mass of copper, because copper is not a molecule, right? Copper is not a molecule. Remember, what is a molecule? Is the combination of 2 or more atoms that are covalently bonded, all right? For example, if we talk of O2, right, that is a molecule. Then we can talk of what? The relative molecular mass, all right? Because for copper, we can't say it's a molecule, right? But O2, it is a molecule. Hence, we talk about what? The relative molecular mass. So I hope you get the difference between relative atomic masses for atoms. For example, what is the relative atomic mass of what? Of fluorine. It's what? It's 16. But what is the molar mass of fluorine? It's not 16, but it's 19. It's 19. That is the what? The relative atomic mass of fluorine. But what is the molar mass of fluorine? It's 19 grams per watt per mole, right? Then what is the relative, molecular mass? What is the relative molecular mass of what? Of oxygen, right? The relative molecular mass, O2, right? The relative molecular mass of oxygen will be what? 2 times what? Times 16, right? So it will be what? 2 times what? Times 16, which is what? 32. If it's the molar mass, it will be 32 grams per watt per mole, right? Then that is the molar mass of O2, all right? But the relative molecular mass, right? It will be what? 32 without what? Units. That is the relative molecular mass, right? No units. Relative why molecular? Because O2, it's a what? It's a molecule, right? Okay, so I hope you can get you get the difference between relative atomic mass, relative molecular mass, relative formula mass, and what? The molar mass. The values are the same, right? The values are the same, but what is different is the issue of what? Of units. No units for relative, but there are units for molar mass, which is grams per what? Per mole, right? Maybe another example dealing with what? The molecules now. For atoms, right? Relative atomic is for atoms. So if, for example, a question can come and say, what is the relative atomic mass of oxygen? Relative for an atom of oxygen. For an atom of oxygen, what is the relative atomic mass? It's 16, right? But relative molecular mass, right? So a molecule, remember O2 in nature is found as a diatomic what? A molecule, right? So it will be 16 times what? 16 times 2. Then remember now they are talking about what? Molecule of oxygen, which is O2, okay? Then it will be 16 times what? Times 2, which is what? 32, right? Then if it's the molar mass of O2, then it will be 32 grams per what? Grams per mole. But if they are saying relative atomic mass for the atom of oxygen, it's 16. But for a molecule of oxygen, which is O2, it will be what? 32. So I hope you now you understand what the difference. But we are using these values from what? From the periodic what? Periodic table. Okay, maybe another example. Let's make another example with what is this? Chlorine, right? So chlorine, the relative atomic mass of chlorine for an atom of chlorine is 35, right? 0.5. That is the relative atomic mass. But what will be the relative molecular mass? Remember, in nature, chlorine is found as a diatomic what? Molecule. So what is the relative molecular mass as a molecule now? It will be what? 35.5 times what? Times 2. Because remember, chlorine is Cl what? Cl2. Then it will be 35.5 times what? Times 2. Okay? So then maybe again you will get, like, moving forward, we will get more examples on that, right? But for now, I think we understand the difference between the relative atomic mass is for atoms, right? And we get that from the periodic table. Relative molecular mass is for molecules, again no units, right? Relative formula mass, again no units, right? Then molar mass, again we are using the same values from the periodic table, but now we have to include what? The units. All right. So let's look at examples. Here we are required to calculate the number of moles, right? So we are focusing on these two equations, right? N equals to mass over molar mass, N equals to number of particles, which is capital letter N, divided by the Avogadro's number. All right. Okay. So here we are requested to calculate the number of moles, actually, yes, the number of moles of atoms in 96 grams of what? Of sulfur, right? So you are given what here? Mass of sulfur, right? It's 96 grams, okay? Then we are given what? This atom, which is what? Which is sulfur, right? They are looking for what? The number of moles. So you can see that you are not given what? The mole, what is this? The molar mass of what? Of sulfur, all right? But you know that you can get the molar mass of a substance if you're given its symbol or if you're given its molecular what? Molecular formula, right? So the symbol, although we're given the name here, but we know the symbol, it's what? It's capital letter S, right? Then we go straight to the periodic table and then we check the relative atomic mass of sulfur. So let's go to the periodic table and check the relative atomic mass of what? Of sulfur. So this is sulfur, right? What is the relative atomic mass of sulfur? It's 32, right? Then if the relative atomic mass of sulfur is 32, what about the molar mass of sulfur? It will be 32 grams per what? Per mole. Same value, but now with the molar mass, there are units, which is grams per what? Per mole, right? Then, so we have the molar mass of what? Of sulfur. which is 32 grams per watt per mole, right? So they want us to calculate what? The number of moles, right? Of what? Of atoms in 96 grams of what? Of sulfur, all right? So the equation, where do we get this equation? Not from the atmosphere, right? But the equation is there on your data sheet, right? You go straight to your data sheet, right? This is your data sheet, and then you are given what? The mass and the molar mass, right? And they want you to calculate what? The number of moles, all right? So this is the equation that we have to use. And you copy that equation as it is, right? From your data sheet, right? So there's no need for you to manipulate it. So sometimes learners, they will just manipulate. So copy that equation as it is first. Then after you can manipulate it. And actually there's no need to manipulate it, right? Remember, when it comes to physics, it's unlike when it comes to your maths, right? When we mark, right? We mark, the first mark is for what? Is for the correct equation. And then the second mark is for the substitution. And then the last mark is for what? Is for the correct answer with the units. All right? So we are not going to give you marks that you have manipulated the equation, you have made something the subject of the formula. There's no need for that. So copy that equation as it is from your data sheet, and then do what is important, okay, for you to get the marks. All right? Then, so here the equation is N equals to mass over what? Over molar mass, right? Then what is the mass? The mass is 96, right? And then what is the molar mass of sulfur? The molar mass of sulfur is 32 grams per mole. Where is that 32 grams per mole coming from? From the periodic table. From the periodic table, what is that we get? We get the relative atomic mass. And then we can convert that relative atomic mass to molar mass just by putting what? The SI unit, which is grams per watt per mole. So here we're having 96 over what? Over 32. So what is 96 over 32? Then you press your calculator. It's what? It's 96 divided by what? By 32. So your 96 divided by 32. So what is 96? 96 divided by what? 32. Okay? What are we getting? We are getting what? 3. So, okay, we are getting what? We are getting 3. But it's not just 3. We are calculating the number of moles. What is the SI unit for number of moles? It's mole, right? So here it's what? Is 3 mole. And again, for you to get a mark for the equation, right, or for the formula, there must be substitution. So if, for example, you can just say, okay, the question says calculate the number of moles of sulfur, or in 96 grams of sulfur, and then you just do this. You just say N equals to mass over molar mass, and then you leave it like that. You are not going to get a mark. For you to be able to get a mark for the equation, there must be substitution. We don't even care whether that substitution is correct or not. But as long as there's substitution, then it's when we'll give you a mark for what? For the equation, or is then we can give you what? The mark for what? For the formula, right? For example, here we can give a mark for the formula, right? Because there is substitution. We don't care whether that substitution is correct or not. But for you to get that mark for the equation, there must be what? Substitution. So that is one of the rules that are being applied when it comes to marking. All right? Then, so correct substitution and then correct answer with what? With units. So this is how we can calculate the number of moles given the mass and what? And the molar mass, right? So it's not something that is difficult. Where did we get the molar mass? From the periodic table. So you need the periodic table for you to get the molar mass. So just convert that relative atomic mass to molar mass. How? Just by putting what? The SI. You use the same value, and then you just include the SI unit. All right. Okay. Calculate the mass of 0.5 mole of H2SO4. Right. So H2SO4, that is sulfuric acid. All right. So they want us to calculate the mass. Right. We are given what? The number of moles. All right. We are also given the molecular formula. So from that molecular formula, we can get, you know, the molar mass, right? How are we going to get the molar mass? We are given sulfuric acid. This is the chemical formula for sulfuric acid, which is H2SO4, right? So let's calculate the molar mass of it, right? So the molar mass of it, how many hydrogen atoms are we having there? There are 2. And what is the relative atomic mass of hydrogen? Relative atomic mass of hydrogen. Go straight to your periodic table. the relative atomic mass of hydrogen, it's 1. There's hydrogen there, there's sulfur, there's oxygen. For sulfur, it's 32. For oxygen, it's 16. All right? So now let's calculate what? The relative, the molar mass. Okay? So we are calculating the molar mass. Okay? So 2 hydrogen atoms multiplied by 1. Where is that 1 coming from? From the periodic table. That is the relative atomic mass of hydrogen. Then 32. There is only 1 sulfur atom there. Hence, it's 32 there. Plus, how many oxygen atoms are we having here? Oxygen atoms, there are how many? There are 4. Then what is the relative atomic mass of oxygen from the periodic table? Right? Relative atomic mass of oxygen is what? Is 16. So it's 4 times 16. Why 4 times 16? There are 4 oxygen atoms in 1 molecule of sulfuric acid. Okay? Hence, we are saying 4 times 16 there. Then what is the total? We add. We don't subtract. We don't multiply here. So we add our relative atomic mass of hydrogen, relative atomic mass of sulfur, relative atomic mass of oxygen. But how many oxygen atoms are there? There are 4. How many hydrogen atoms are there in 1 molecule of sulfuric acid? Is 2. Hence, we have 2 there. Hence, we have 4 there. All right? So what is the total? Is 98 grams per what? Per mole. Okay? So now, what are we having? We are having the number of moles. We are having the molar mass, right? Then we can calculate mass of what? Of sulfuric what? Acid in 0.5 moles, right? Then the equation again, you can see they didn't manipulate the equation. The equation is the same, is the way it is from what? From the data sheet is what? Is N equals to mass of a what? Of a molar mass, right? So N equals to mass of a molar mass, right? What are we given here? Correct substitution, right? So there's no need for you to, try to make, M the subject of the formula there, right? I'm not saying you are not allowed to do it, but first thing that we want to see is the equation as it is from what? From the data sheet, right? Then from there, it's when now we can manipulate it. But if there's no need, it doesn't mean that you are going to get more marks than others. Rather, copy the equation as it is and then substitute from that equation. As you can see here, what is the number of moles? Is 0.5. Do we have the mass? No, we are looking for the mass, right? Then what is the molar mass? Is 98, right? Then from here, we can then calculate what? The mass of what? The mass of what? Of 0.5 mole of what? Of sulfuric acid. And the answer there is what? Is 49. So where is that 49 coming from? It's 0.5 times what? Times 98. So what is 0.5 times 98? 0.5 times what? 98. So 0.5 times 98, we are getting what? 49. And then 49 what? Is 49 grams because we are calculating what? The mass. Then we'll get a mark for correct equation. Remember, for you to get that mark, there must be what? Substitution. We are not checking whether that substitution is correct or not, but there must be what? Substitution. Even if here we're having 10, here we're having 100, we don't care. But as long as there's that substitution, then we'll get the mark for what? For the formula. All right? So there's a mark for the formula there. There's a mark for correct substitution. There's a mark for correct answer with what? With units. So if you just wrote 49 instead of 49 grams, you will lose a mark for the final answer. But for you to get the mark for the final answer, it should be, the value in what? In the SI what? In the SI unit. All right? So here you'll get what? 3 marks. Ne? So another equation, calculate the mass, right? Calculate the mass of 2 mole of an ionic compound. Okay, the mass of 2 mole of an ionic compound is 80 grams, right? So we are given the number of moles. We are given what? The mass of that ionic what? Compound, right? So then calculate the formula mass, right? Of the compound, or the formula mass of that ionic compound, right? So remember, we talked about the relative atomic mass. Remember, that one is for atoms. Relative molecular mass is for what? Is for molecules, right? Relative formula mass is for ionic compounds, right? But when we calculate those, we use the same values. It's just that they have specific names, all right? So for atoms, it's the relative atomic mass, and then for molecules, right? Remember, molecules, right? a molecule that is the combination of two or more atoms that are covalently bonded. For example, your O2, your CO2, it's a molecule, right? So for molecules, it will be relative molecular mass. And then for ionic substances, it's a relative formula mass. So for ionic substances, is the relative what? Formula what? Relative formula what? Formula mass, all right? That is for ionic substances, right? So ionic substances, remember those atoms, they are not covalently bonded, but there's an ionic bond between those what? Between those atoms, right? For example, your NaCl, it's an ionic compound, right? Remember in grade 10, you did look at what? Chemical bonding. So different types of bonds or chemical bonds, right? Or interatomic forces. So one of those is ionic what? Is ionic what? Bond. An ionic bond exists between a metal and what? And a non-metal. So NaCl, Na is a metal, Cl is a what? It's a non-metal. So then those two atoms, there's an ionic bond between those two atoms. So hence the molecule will, sorry, the substance will be what? An ionic substance or an ionic what? Compound, right? So the mass of 2 mole of ionic compound is 80 grams, right? Calculate the formula mass of the compound. Calculate the formula mass of what? Of the compound, right? So they are looking for what here? The formula mass. The formula what? Mass. The formula mass or the relative formula mass. Why formula mass? We are dealing with what? An ionic compound. If we are dealing with a molecule, right? Or a covalent compound, it was going to be what? Molecular mass, the relative molecular mass. If we're dealing with what? An atom, it was going to be relative atomic what? Atomic mass. But the values are the same, is the values from the periodic table, all right? So first thing that we need to do here, right? First thing that we need to do here is to calculate what? The molar mass of that substance, okay? The molar mass of what? Of that substance. So the molar mass of that substance, the equation is N equals to number of moles, equals to what? Mass over what? Over molar mass. So the mass is 80, right? Number of moles is 2. Then the molar mass, so the molar mass will be what? 80 divided by what? By 2, all right? So what is 80 divided by 2? 80 divided by 2 is what? Is 40 grams per watt per mole. So that is the first thing that we'll get here. Using this equation, M is the molar mass, which is measured in grams per watt per mole. Therefore, the relative formula what? Mass, right? Will be what? 40. Without the SI what? The SI unit. Okay? That is the relative formula what? Relative formula mass. So no SI unit. So what we got here is the molar mass, which is what we'll get when we are using this equation given the number of moles and the mass, right? We'll get the molar mass with units. But remember, the values are the same. What is different is that when it comes to the molar mass, I've explained already that when it comes to the molar mass, there's an SI unit, which is grams per mole, but relative atomic mass, relative formula mass, relative molecular mass, no units for that, okay? And the relative atomic mass is for atoms, which is what we get from the periodic table. Relative molecular mass is for molecules, covalent compounds, right? Then the relative formula mass is for ionic what? Ionic compounds, all right? So, but the values are the same. It's just that when it comes to your molar mass, they are units. Relative, there are no what? SI unit, all right? So if we can check these examples, we're using the same equation, N equals to N, where N is the number of moles, mass over what? Over molar mass, right? So which means that when it comes to this equation, right, you can calculate the number of moles given mass and molar mass, right? When it comes to this equation, you can calculate mass given the number of moles and the molar mass. When it comes to this equation, for example, this example, we were using what? Number of moles and mass to calculate the molar mass, right? So with this equation, since there are 3 physical quantities there, right, if you are given 2 of those, you can calculate the one that is missing or the one that is unknown, all right? So it's what we were focusing on. Now, let's use the second equation the number of moles equals to number of particles divided by Avogadro's number, right? So when it comes to this equation, obvious, they won't say calculate the Avogadro's number. It's a constant. It is there on your data sheet, right? So check on the table of constants. Table of constants is there, right? It is there. 6.02 times 10 to the power 23 per what? Per mole. That is Na, which is Avogadro's constant or Avogadro's number. So they can't say calculate that. It is there. It's a constant, so it doesn't change. So you won't find a question where they will say calculate Avogadro's constant or Avogadro's number. No. Right. So in this equation, what we can calculate is the number of particles given the number of moles of those particles, right? We can calculate the number of moles given the number of particles, number of atoms, number of molecules, number of ions, and number of formula units. All right? So we can calculate the number of moles given that. Or if we are given the number of what? Of moles, you can calculate the number of particles, atoms, molecules, ions, and what? And formula units. But they won't say calculate the Avogadro's constant or the Avogadro's number. It's a constant. It is there on your data sheet, right? Or the table of constants. So there's no need for you to memorize it. As long as you know that Na is Avogadro's constant, even if you don't know that value, it is there, and it's all right to have it when we are writing whether it is a formal or informal assessment. If a question wants you to use that, okay, it's all right to have it, okay, and you'll always be given that, okay. Then let's check now using this equation, calculating the number of moles, calculating the number of particles, right? So calculate the number of atoms. Calculate the number of atoms in 1.2 grams of what? Of carbon, right? So you are given the mass, right? Of what? Of carbon. They are looking for what? The number of atoms. And the number of atoms is particles, which is N there. Okay? Sharp. Then if you want to go straight to this equation, right? Are you given the number of moles? No. Right? But you are given what? The mass. If you are given the mass, you can get the number of moles, right? Using which equation? N equals to mass over what? Over molar mass, okay? So what is the mass? It's 1.2. What is the molar mass of carbon? It's 12 from the periodic table, okay? Then you get what? The number of moles as 0.1 mole, right? You have the number of what here of moles is 0.1 mole, all right? Then now we can go straight to that equation because now we have the number of moles. Then we can calculate the number of what? Of atoms, okay? So the number of moles, it's what? It's 0.1, right? So if the number of moles is 0.1, what is the number of atoms, right? The number of atoms, N equals to what? Number of atoms divided by what? Avogadro's constant, okay? Number of moles is what? It's 0.1. And then we are looking for a number of atoms there. And what is Na? 6.02 times 10 to the power what? 23. Okay? Then you'll get the number of what? Of atoms. So what is 0.1 times 6.02 times 10 to the power 23? Is 6.02. So here we have 6.02 times 10 to the power what? 22 what? Atoms of what? Of carbon. Okay? So you can calculate the number of atoms using that equation. But for you to be able to calculate the number of atoms, you need the number of moles. In this case, we are not given the number of moles, but we're given the mass. So we converted that mass to number of moles using the equation N equals to mass over what? Over molar mass. So these are some of the equation, the questions that you'll get. It's not always the case that they will give you the number of moles, right? So sometimes they will, they will want you to calculate the number of moles, and then from calculating the number of moles, then use the equation N equals to number of particles divided by Avogadro's number to calculate what? The number of atoms or the number of what? Of particles, right? Then another example here. Determine the number of atoms in 254 grams of iodine. Iodine is a diatomic molecule. It's I2, the chemical formula, right? It's I2. So they are looking for what? The number of atoms again. So are we given the number of moles so that we can go straight to that equation? No, we are not given the number of moles. So first thing that we need to do is to convert that mass, right, to number of moles. Using which equation? It's mass over what? Over molar mass, which is what here? 254 divided by what? 2 times 127. Where is that 127 coming from? Molar mass, we are using the relative atomic masses from what? From the periodic table. So let's check iodine. Iodine, the relative atomic mass of iodine is 127. But for the molecule of iodine, which is I2, it will be 127 times what? Times 2. 127 times what? Times 2. So it's 127. As you can see here, it's 127 times what? Times 2. So what is 254 divided by 2 times 127? 254 divided by 2 times 127, it's what? It's 1. So now we have the number of moles of iodine, right? Molecule. Then we can calculate the number of atoms, right? So how are we going to calculate the number of atoms? The equation is number of moles equals to number of particles divided by what? The Avogadro's constant, all right? So we have the number of moles, right? We have the number of moles now. So the number of moles, it's what? It's 1. We are looking for the number of atoms, and we have the Avogadro's constant from the data sheet or from the table of constants, which is 6.02 times 10 to the power what? 23, right? Then the answer here will be number of atoms will be 6.02 times 10 to the power what? 23. So 1 mole of a substance is equal to Avogadro's constant. So these are the number of atoms of what? Of iodine. Okay. Okay. So it's n equals to what? Let's say 1 equals to n over what? 6.02 times what? Times 10 to the power 23. So another thing which is important here. Remember, we are calculating the number of what? So here, what are we going to? What is this actually? This is the number of molecules, right? So this is the number of what? Of molecules. So the molecule of iodine is I2, all right? So this is the number of molecules. But remember here, they're looking for what? The number of atoms. So how many atoms of iodine are there in 1 molecule of iodine, right? How many atoms are there in 1 molecule of what? Of iodine. So iodine is I2. So how many atoms are there in 1 molecule of iodine? There are 2. Hence here we have to say 2 multiplied by 6.02 times 10 to the power what? 23, right? Which is equals to what? 1.2 times 10 to the power 24 what? Atoms. I hope this is making sense, right? So the molecules here, the molecules is 6.02 times 10 to the power 23, okay? Those are the molecules, right? So because we have 1 molecule of iodine here, right? But how many atoms of iodine are there in 1 molecule? There are 2. Hence here we have multiplied by what? By 2, okay? It's like, let me check if we don't have another example that will explain this. Let me just give you another example, right? So you have, let's use H2SO4. H2SO4, right? So that example where we're given what? Let's go back. This example. Let's use this example. Here, let's say you are looking for what? The number of atoms, right? The number of atoms of oxygen in 1 molecule of sulfuric acid, okay? Already we have calculated, we are given what? The number of moles, all right? So n equals to what? Number of particles divided by what? Avogadro's constant, right? Number of moles is 0.5, right? N over what? Na 6.02 times 10 to the power what? 23, right? Then the number of particles, okay? The number of particles here will be half of 6.02 times 10 to the power 23. So let's try and calculate that, right? And see. Okay, so here, what are we having? We are having 0.5. You multiply that by what? 6.02, okay, times 10 to the power what? 23. 23, right? So 0.5 times 6.02 times 10 to the power what? 23. This is what we are having, right? It's 3.01 times 10 to the power 23, okay? So 3.01 times 10 to the power what? 23, okay? 3.01. So here we are having what? 3.01 times 10 to the power what? 23, right? So these are the number of what? Of molecules, right? So these are the number of what? Of molecules. But how are we going to get the number of oxygen atoms, right? So how many oxygen atoms are we having in one molecule of sulfuric acid? There are 4. So to get the number of oxygen atoms in one, so these are the number of molecules, right? So how many atoms are there, or oxygen atoms are there in one molecule of sulfuric acid? It's 4, right? So then we'll say 4 times 3.01 times 10 to the power 23. Then we'll get the number of oxygen atoms in one molecule of what? Of sulfuric acid. Why are we multiplying that number by 4? How many atoms of oxygen are there in one molecule of sulfuric acid? There are 4. Then the number of molecules, right? It's 3.01. So in that one molecule of sulfuric acid, how many oxygen atoms are we having? There are 4. Then that is why we are multiplying that by what? By 4. If they were looking for the number of hydrogen atoms in one molecule of sulfuric acid, we are going to say, check the number of atoms of hydrogen in one molecule of sulfuric acid. It's 2. Then we're going to multiply this number by what? By 2. I hope it's making sense, right? So why are we multiplying by 4? How many oxygen atoms are we having in one molecule of sulfuric acid? There are 4. If they were looking for the number of hydrogen atoms, how many hydrogen atoms are we having there? There are 2. Hence, we have to multiply that by what? By 2. Okay. Then here, what is 4? What is 4 times? What is 4 times 3.01 times 10 to the power 23? So we are multiplying this by what? By 4. What are we getting there? 1.204. 1.204. 1.204. So here it's 1.204 times 10 to the power what? 24. Then these are the number of oxygen atoms in one molecule of what? Of sulfuric what? Sulfuric what? Acid. So the number of molecules of sulfuric acid is this, right? This is the number of molecules of sulfuric acid. So in this number of molecules, how many atoms of oxygen? Then we'll multiply that by what? By 4. Then we'll get the number of oxygen what? Atoms. All right. Then, so I hope it's making sense, learners. So these are other examples where we have to calculate the number of moles of atoms. Ne? So calculate the number of moles given what? The mass. So here you're given the mass of calcium is 120. Then they're looking for what? The number of moles. So I think we did look at examples like these ones, right? Okay, so I think we have to move here from here. Then calculating the mass, again, we did look at this. So calculating the mass given what? The number of moles, and calculate the molar mass from the periodic table. The values are from the periodic table. Then we can calculate the mass, all right? So same thing even here, right? We are given the what? The number of moles. They are looking for what? The mass, right? So MgO, M is magnesium, O is oxygen, and then what is the relative atomic mass of Mg, which is your magnesium, is 24 from the periodic table, and then for oxygen is 16. What is 24 plus 16 is what? Is 40. Then you can calculate the mass. The equation is from the periodic table, sorry, it's from the data sheet. N equals to mass over molar mass. where n is the number of moles, in this case is 0.6, and then mass is what we are looking for. Molar mass is 40, then we'll get what is this, the mass, right? So I think it's the same examples here. So here you are looking for what, the molar mass, and then here we're also looking for what, for the molar mass, right? So when you use this equation, you can calculate three things. For example, the number of moles given the mass and molar mass. Calculate what mass given the number of moles and molar mass. Calculate molar mass given the mass and what, and the number of moles. So that is the relationship between moles, mass, and what, and molar mass, right? Then molar gas volume. So this one is for gases, right? So molar gas volume and concentration. Remember the relationship between what the number of moles and Avogadro's constant. 1 mole of a substance is equal to Avogadro's number. So we did talk about that, okay? Then again, even for gases, 1 mole of a gas occupies 22.4 cubic decimeters at STP. So what is important here, right? STP, it's the standard temperature and pressure. So what is the standard temperature, right? Standard temperature is it's what? Let's check from the table of constants. Ne? So standard temperature. Yeah. So the standard temperature, it's here. Standard temperature, what is the value of standard temperature? Is 273 Kelvin, okay? And then what is the value of standard pressure? Standard pressure, this is the symbol. This is the symbol for standard temperature. What is the value of standard temperature? Is 1.013 times 10 to the power 5 pascals, which is the same as 101.3 kilopascals, right? So that is the value of the standard pressure, and then this is the value of standard temperature, okay, which is the same as 0 degrees 0 degrees Celsius, okay. So those are the values. So the value of standard temperature is 273 Kelvin, and then the value of standard pressure is 101.3 kilopascals, or 1.013 times 10 to the power 5 pascals. All right. Then at standard temperature and pressure, yes, at standard temperature and pressure, 1 mole of a gas, 1 mole of a gas at standard temperature and pressure. Standard temperature, remember, is 273 Kelvin, or 0 degrees Celsius, right? And then standard pressure is 1 atmosphere, or 101.3 kilopascals, or 1.013 times 10 to the power 5 pascals. Ne? So at standard temperature, 1 mole of a gas occupies 22.4 cubic decimeters. Okay, so 1 mole of a gas at standard temperature and pressure occupies 22.4 cubic decimeters. So 1 mole, right, of a gas at standard temperature and pressure occupies 22.4 cubic decimeters. All right. So number of moles is given by V over Vm, where at standard temperature and pressure, right? So 1 mole of a gas, why are they saying it occupies it occupies 22.4 cubic decimeters, right? Vm is the molar gas volume, right? So it's the molar gas volume. And what is the molar gas volume? Molar gas volume where at standard temperature and pressure. So molar gas volume at this temperature and this pressure, which is the standard temperature, standard pressure, or what is the molar gas volume at 273 and 101.3 kilopascals, right? So let's check the value of the molar gas volume at standard temperature and pressure. The molar gas volume at standard temperature and what? And pressure. So you can see that these values are very, very important. Right? Molar gas volume at STP is 22.4 cubic decimeter per mole. Right? At standard temperature and pressure, at 273 Kelvin and 101.3 kilopascals, right? What is VM? What is the molar gas volume? Is 22.4 cubic decimeters per watt per mole. So molar gas volume is 22.4 at which temperature? 273, and at which pressure? 101.3 kilopascals. It is 22.4. So you know what is the problem with this equation? V number of moles equals to V over Vm, right? V over Vm, this equation, right? This Vm, right? It is 22.4 cubic decimeter per mole at what? At STP. At STP, or at 273 Kelvin, 101.3 kilowatt pascal. It is what? 22.4. But if I can change this to 275, right? 101.3 kilopascals, the value cannot be the same. It can't be 22.4. It is 22.4 at 273, or at 0 degrees Celsius and 101.3 kilopascals. But if you can change this to 275 and leave this as it is, it's no longer 22.4. It is 22.4 at standard temperature and what and pressure. I hope that is that is clear, learners, right? It is 22.4 at standard temperature and what and pressure. But if I can change that temperature to 272, is no longer standard temperature. All right? Okay? Even if I can leave this as it is. But if I can change this to 273, sorry, to 272, 274, 275, it's no longer standard temperature. So this value cannot be 22.4. It is 22.4 cubic decimeter per mole at STP. At STP, standard temperature, 0 degrees Celsius, 273 Kelvin. Standard pressure, 101.3 kilopascals, or 1 atm, or 1.013 times 10 to the power 5 pascals. It's when VM becomes 22.4. So what am I trying to say to you? As long as they didn't mention STP, you can't use 22.4. You lose 22.4 if they mention that the gas is at STP, standard temperature and what? And pressure. I hope it's making sense, learners, right? Then, so in cases like, okay, let's check here. Right? So 1 mole of a gas occupies 22.4 cubic decimeters at standard temperature and what and pressure, right? So Vm is the molar gas volume at STP. It's what? 22.4 cubic decimeters per watt per mole. But it is 22.4 at STP, standard temperature and what and pressure. So if you are given different temperatures, different pressure, right? You can't use 22.4. In a case where they're saying at this temperature, 272 Kelvin, and maybe 101.3 kilopascals, right? They have to give you what? VM at that temperature, right? When are they going to, are they not going to give you VM? They are not going to give you VM at STP, because that VM at STP is there on your what? On your data sheet. But when they say 272, we can't use 22.4. They have to give us what? VM. I hope it's making sense. That VM, that molar gas volume, that 22.4 is for STP. But if the temperature has changed to a different temperature, 2 degrees Celsius is no longer 0, and the pressure is no longer 101.3, right? Then they have to give us what? Vm, if they want us to calculate what? The number of moles of that gas. I hope it's making sense, right? Then, another thing that is very, very important, it's not always the case that you will be given, for example, when it comes to this equation, right? N is the number of moles. V is volume of a gas. Not just volume of anything, right? It's volume of a gas, right? Not volume of a solution. Volume of a gas, right? Which is measured in cubic decimeters, right? Then Vm is the molar gas volume. We are not saying it's 22.4. This is molar gas volume. But if they mention that the gas is at STP, is when we'll say 22.4 cubic decimeter per watt per mole. But if they didn't mention STP, then if they want us to calculate the number of moles, right, of a gas, then they have to give us what? The value of what? Of the molar gas what? Molar gas volume. It's 22.4 at STP. But at different temperatures, right, or different pressures, right, it can be 22.4. It's 22.4 at STP. I hope it's making sense, right? Then this V is not just any V, it's volume of a gas, right? It's volume of a gas at a certain temperature and pressure. Volume of a gas at a certain temperature and pressure, right? Okay, then another thing which is important, learners, it's not always the case that when they want us to calculate the number of moles of a gas, right, they will give us volume in cubic decimeters. They can give us volume in what? In cubic what are centimeters, right? They can give us volume in milliliters. They can give us volume in what? In liters, right? So what do you need to know, right? One cubic centimeter is equals to 1 milliliter, right? And then this is equals to what? So for example, when you're using this equation, V over Vm, N equals to V over Vm, your V should be in cubic decimeters, right? So if you're given volume in cubic centimeters, in milliliters, right? So from cubic centimeters to cubic decimeters, you divide by 1,000, right? So this is the same as 1 times 10 to the power what? Negative 3 cubic watt decimeters, right? Equals to 1 times 10 to the power negative 3 watt liters. So in other words, 1 cubic decimeter is equals to 1 liter. So 1 liter is the same as 1 cubic watt cubic decimeter, right? So if you are given volume, because it's what they do in most cases, they can give you volume in milliliters, they can give you volume in cubic centimeters. So cubic centimeters to cubic decimeters divide by 1,000 to convert that to cubic decimeters, all right? And 1 liter is the same as 1 cubic watt cubic decimeter. So those are the things that are very, very important there, right? So let's look at examples, right? Now using this equation, number of moles equals to V over Vm, right? So we can calculate the number of moles given the volume, right? And what the molar gas what? Volume. So let's check this one. What are they looking for here? They are looking for what? The mass, right? They are looking for what? The mass. Calculate the mass of 5.6 cubic decimeters of carbon dioxide at STP. Okay, the gas is at STP. So already we have the value of that because it's at STP, right? We are also given what? The volume at STP, all right? So we can calculate the number of moles, all right? So the number of moles, what is V? It's 5.6, and there's no need for us to convert because you're given V in cubic decimeters. Vm, because they're saying it is at STP. At STP, what is the molar gas volume? Is 22.4. But if they didn't say STP, we are not going to assume that the gas is at STP. All right? So we cannot assume. They have to mention STP. If they didn't, it means that it is at a different what? It's at different temperature and pressure. Then they have to give us what? Vm. It's 22.4 at STP. Then we get the value there as what? 0.25. What? Mole. Then after calculating the number of moles, we can use this equation to calculate what? The mass now, right? The number of moles, 0.125. We are looking for what? The mass. What is the molar mass of carbon dioxide? Carbon is 12. That is the relative atomic mass of carbon from the periodic table. Oxygen, the relative atomic mass is 16. But how many oxygen atoms are we having? There are 2. So it will be 2 times what? Times 16. So in other words here, for the molar mass of carbon dioxide will be 12 plus 2 times what? 16. 2 times 16 is 32 plus what? Plus 12. So 32 plus 12 is going to be what? 44. So it's 44 grams per what? Per mole. That is the molar mass of carbon dioxide. Then here we'll divide by what? 44. Then what will be the mass? The mass will be 0.25 times what? Times 44. And what is 0.25 times 44? It's 11. So it is going to be what? 11 what? Grams. So simple, right? Simple. Then, so let's check this one. Calculate the volume of the following gases at STP. At STP. At STP, right? So 2 mole of carbon dioxide, right? So 2 mole of carbon dioxide, then N equals to V over what? Over Vm. This is the equation that we have from our data sheet, right? So copy that equation as it is, and then from there, let's substitute. We are given the number of moles. What is the number of moles? Is 2. We are looking for what? Volume. Then they're saying it is at STP. What is Vm at STP? Is 22.4. So what is 22.4 times 2? Is 48. This is 48. So not 48, but 44.8 what? Cubic what? Decimeters. Right. Then we can get the volume of carbon dioxide at STP with those number of moles. All right. Then 3.3 mole of hydrogen gas, right? We are looking for the volume. Vn equals to V over what? Over Vm. Number of moles, 3.3. We are looking for V. This is at STP, so it's 22. The Vm, or the molar gas volume, so it's 22.4. Then what is 22.4 times 3.3? The volume of hydrogen gas, it's going to be what? 73.92 cubic what? Decimeters. Then it's a mark there for the correct equation, correct substitution, and the correct answer with what? With units. Then 0.45 mole of neon. Neon is a gas, right? It's an inert gas or a noble gas. We all are aware of that. You did that in grade 10. Then they're looking for what? For the volume. So the volume, number of moles equals to V over Vm, because they're looking for the volume of this gas at what? At STP. Number of moles 0.4. We are looking for the volume. Vm is 22.4. Why 22.4? The gas is at STP. Then what will be the volume? The volume will be what? 10.08 cubic what? Decimeters. Right. So that is volume of a gas at STP. Calculating the volume of a gas at STP. All right. So if they change that STP to a different temperature, different pressure, they have to give us Vm at that temperature. But at STP, we are sorted. It is there on our data sheet as 22.4 cubic decimeters per watt per mole. So please be careful when it comes to that. So when they say calculate volume of a gas, right, check whether it is at STP or is at different temperature and different pressure there, right? But if they say at STP, your Vm will be 22.4. But if it's different temperature, they have to give you what? Vm there. Or they will say calculate that Vm. Right? So they can say calculate Vm here. Vm is not a constant. Vm is a constant for STP, which is 22.4. I hope it's making sense, learners. Ne? Vm is not a constant. It's not like Avogadro's number. Na is always 6.02 times 10 to the power 23. But that Vm is not a constant. It's a constant for a gas that is at STP. But for a gas that is at a different temperature or different pressure, then it's not constant. It's different. It's not always. It's 22.4. It's 22.4 for which temperature? 0 degrees Celsius or 273 Kelvin, and for which pressure? 101.3 kilopascals or 1 atm or 1.013 times 10 to the power 5 watt pascals. So Vn, don't say there's something wrong with the question if they say calculate Vm. you will be asked to calculate Vm, but you won't be asked to calculate Vm at STP because that value is there on your data sheet. I hope it's making sense. All right. Then, again here, it's the calculation of what? Of the volume at STP. And then, now I want us to look at what? The concentration of a solution. Right? Definition of concentration of a solution. So how are we supposed to define concentration of a solution? Concentration of a solution is defined as the number of moles of a solid per cubic decimeter of what? Of a solution. This is how we have to define concentration of a solution. So concentration is defined as the number of moles of a solid per cubic decimeter of what? Of a solution. And how can we calculate concentration of a solution? Concentration of a solution is given by number of moles divided by what? Volume, right? So concentration is measured in mole per cubic decimeter, and then N there is the number of moles in mole, and then V. Please be careful when it comes to this V. There's V when it comes to N equals to V over Vm. This V here is the volume of a gas at a certain temperature, right? And pressure, okay? What is this V? Is the volume of a solution. Volume, this is not volume of a gas, but the volume of what? Of a solution, all right? So this V here is volume of a gas. This V here is the volume of what? Of a solution, which is still measured in what? In cubic what? Decimeters. So please be careful when it comes to those two V's. This V is volume of a gas. This V is volume of what? Of a solution. All right. Then we can also calculate concentration of a solution using the equation C equals to mass over molar mass times the volume. Right. So M is the mass of that substance or the solution, which is measured in grams, and then M is the molar mass of that substance, and then V is the volume of that substance or the volume of that solution. All right. So these are the two equations that we can use to calculate what? Concentration of a solution. All right. C equals to N over V, and C equals to mass over molar mass times what? Times the volume. So these are the two equations. And please be careful, learners, when it comes to V. What is this V? Is the volume of a solution. What is this V? Is the volume of a gas at a certain temperature and what? And pressure. All right. Then these are the calculations, or concentration calculations. So let's look at the first one. They want us to calculate the concentration of a solution that contains 0.2 mole of copper 2 sulfate in 250 cubic decimeters of what? Of water. All right. So you're given the number of moles of copper 2 sulfate. What is important here? One, it's okay, one of the things here, you know what I'm thinking of here? Another thing that they can add here when it comes to this question, although they are looking for the concentration, right? They can also say calculate the mass, right? They can say calculate what? The mass, right? Of this solution, right? But let's focus on the question for now. They want us to calculate what? The concentration. So the concentration is given by C equals to N over what? Over V. We are given what here? The number of moles. We are also given what? The volume. But check the volume there is not in cubic decimeters. It is in cubic what? Centimeters. So we have to convert those cubic centimeters to cubic decimeters. All right. So concentration is N over V. What is N is 0.2. And then what is the volume? So we can't use 250 as it is because that 250 is in cubic centimeters. But we want that V in what? In cubic decimeters. So how do we convert cubic centimeters to cubic decimeters? We divide by 1000, or we can say multiply by 10 to the power negative 3. But if you divide that 250 by 1000, you will get what? 0.25 cubic what? Decimeters. So here we will divide by 0.25. All right. So what is 0.2 divided by 0.25? 0.2. All right. 0.2, right, divide by 0.25. Where is this 0.25 coming from? We have divided 250 by what? By 1000, okay? So what is the answer here? Is 4 over 5. what is that? 4 over 5 is 0.8. Okay, so we have 0.8, so which means that the concentration here of the solution is 0.8 mole per cubic watt decimeter. Okay, so 0.8 mole per cubic watt decimeter. All right, then maybe we can even interpret, especially for the grade 12s, we can even interpret the concentration of that solution, whether this solution is concentrated or dilute. All right, so it's going to be dilute, right? So if the concentration of the solution is above 1, right, or is from 1 upwards, then that solution is what is concentrated, but this one is below 1, right? So the concentration of this solution is below 1. So if it's below 1, then it's going to be what? A dilute solution. So this is a dilute solution of what? Copper 2 sulfate, which is CuSO4. Why am I saying it's dilute? Because the concentration of it is less than 1. So if the concentration is less than 1, then how do we interpret that answer? So if it's less than 1, it means that it's dilute, and then if it's greater than 1, it is going to be what? Concentrated. So it's dilute, this one, because the concentration is less than 1. All right, so for grade 12s though. Okay, then let's check other examples. Calculate the concentration of 250 cubic centimeter solution, right? If it contains 73 grams of hydrochloric solution. All right, so they are looking for what? The concentration of hydrochloric acid. Okay, so how are we going to calculate that concentration? So concentration, there are two equations that we can use. We can use C equals to N over V. So C equals to N over what? Over V. But are we given the number of moles here? We don't have number of moles. So first thing that we need to do here is to calculate the number of moles. Yes, we have the volume, right? But we don't have number of moles. We don't have a concentration. So we are having two unknowns there. So so if you're having two unknowns, we have to find the first one. For example, here it should be the number of moles. How can we get the number of moles given the mass of a substance? All right, so N is equals to mass over what? Molar mass, right? So the mass, it's what? Is 73. And then what is the molar mass of hydrochloric acid? The molar mass of hydrochloric acid, hydrogen is 1, and then chlorine is 35.5. So what is 1 plus 35.5 is 36.5. So here is 36.5. So we have 73 divided that by what? What is this? 73 divided by 36 point what? The mass, yes, is 73, and then the molar mass is 36 point what? 0.5. Then let's calculate what? The number of moles. So the number of moles, mass is 73, molar mass is 36.5. So let's calculate that. 73 divided by 36.5. 73 divided by 36.5. Okay, it's 2. Ne? So it's 2. So it means that here we are having how many moles? 2 moles. 2 moles, right? So after getting the number of moles, then now we can calculate what? The concentration. So concentration is C equals to N over what? Over V. So the number of moles is 2. And what is the volume? The volume is 250 cubic centimeters. So you have to convert cubic centimeters to cubic decimeters, right? So it will be what? 250 divided by 1,000, okay, which is going to be what? 0.25. So your answer, what is 2 divided by 0.25? 2 divided by 0.25. So 2 divided by 0.25. The answer here is what? Is 8, okay? So it's 8. So if here it's 8, so it's 8 mole per cubic watt decimeter. So that is the concentration of hydrochloric acid. So it's concentrated, right? You can see, and it's too concentrated, right? So because its concentration is above 1 and it's far from 1, right? So to interpret that answer, whether the solution is dilute or concentrated. So this one is concentrated because its concentration is greater than what? Greater than 1. But if it was less than 1, it was going to be what? A dilute, solution. Then maybe grade 12s, you are aware of the difference between a dilute solution and what? And the concentrated solution. Concentrated solution contains what? Large amount of what? For example, in this case, this is an acid, hydrochloric acid. So is this hydrochloric acid dilute or concentrated? Ne? So what is a concentrated acid? Concentrated acid contains large amount of an acid in proportion to the volume of water. What is a dilute acid? Contains small amount of what? Of an acid in proportion to the volume of what? Of water. So this is hydrochloric what? Acid. So is this hydrochloric acid dilute or concentrated? It is concentrated because its concentration is greater than 1. So it's a concentrated solution of hydrochloric what? Acid. Right? But if it was less than 1, it was going to be a dilute solution of hydrochloric what? Acid. But again, grade 12s, ne? If yes, we understand that this is concentrated, right? A hydrochloric what? Acid. Okay? Concentrated hydrochloric acid, but still this does not change the strength of this acid, right? It is still what? A strong what? A strong acid. So this is a strong acid which is concentrated, but this strong acid can also be dilute. All right, it can also be dilute. If, for example, we got this as 0.8, it was going to be what? Dilute solution of hydrochloric acid, but which is what? Strong. Okay, so grade 12s, they understand that better. But this is one of the methods that you can use to calculate the concentration of this solution, right? Start by calculating the number of moles using the mass, and then from there calculate the concentration after getting the number of moles. Or just go straight, because this equation is there. Just go straight to C equals to what? Mass over molar mass times what? Times volume. What is the mass? The mass is 73. And then what is the molar mass? So the molar mass is 36.5. What is the volume? Is 0.25, not 250. So it's 0.25. Sorry about that. So it's 0.25. So we are having 73 divided by 36.5 times 0.25. So let's check if we are getting 8. Let's check if we are getting 8. So we have 73, divide that by 36.5, multiply that by 0.25. Then, okay, I think this is what we need to do here. It's, let's check 36.5, multiply that by 0.25, 0.25, right? This is what we have, ne? This is what we have, right? Then 73, okay, what are we having here? We're having 9.125, okay? That is 36.5 times 0.25, 9.125. Then we have 73 divided by 9.125, okay? Yeah, we are also getting 8, right? We are also getting 8. So this is another method, right? So, but it doesn't matter, you will get the same marks whether you use this method or that other method. So here is just the combination of the two equations, C equals to N over V and N equals to mass over what? Over molar mass. So we are still getting 8 here, mole per cubic what? Per cubic decimeter. All right. So these are the two methods that you can use to calculate what? To calculate the concentration of a solution. Then you can also interpret it, especially the grade 12s. You can even, actually grade 11, grade 12s, you can interpret those answers of concentration. If the concentration of that solution is less than 1, it means that the solution is dilute, right? It contains, small amount of that substance in proportion to the volume of water, right? Then if the concentration is greater than 1, it means that that solution is concentrated. It contains a large amount of that substance in proportion to the volume of water. For example, in this case, it's concentrated because the concentration is 8. It means that this solution contains large amount of hydrochloric acid in proportion to the volume of water, right? It contains large amount of HCl in proportion to the volume of what? Of water. So then this one, it contains 70 grams of silver nitrate. They want the concentration of this silver nitrate. So again, you can just go straight to C equals to M divided by MV, because we are given the mass, right? And we are also given what here? What else is given here is the volume, right? Which is, we are still using 250. So here, what are we having? We are having the mass as 70, okay? Molar mass, the molar mass is 170. Where is 170 coming from? So from grade 10, you did what names and formula of substances. So what is silver nitrate? The chemical formula of silver nitrate is Ag, is silver, right? And then the nitrate is NO3 what? Minus. So this neutralize this, then we have Ag, NO what? NO3. That is the chemical formula for what? For silver what? For silver nitrate. So it's silver ion versus a nitrate ion. So it's Ag plus and NO3 minus. So that plus neutralize that negative, all right? Then at the end we have AgNO3. That is the chemical formula for silver what? Silver nitrate. So silver nitrate is AgNO3, and then Ag, it's 1OH, that is the relative atomic mass of Ag, and then N is 14, and then oxygen is 16, but there are 3 oxygen atoms, hence there we've multiplied by 3. So we have 170 there. So it's 170 grams per mole, and then you multiply by the volume, which is 250 cubic centimeters, and then cubic centimeters to cubic decimeters divide by 1000. Then here is 0.25. And let's see if we are getting that 1.65 that they got with the method that we have used for the previous example. So it's 70. So it's 70 here. So here I'm having 170. I'm starting with the denominator times 0.25. So I'm getting what here? 42.5. I'm getting 42.5. Then 70 divided by answer, ne? Which is 42.5. Let's see. We are getting what here? We are getting 1.65. 1.65. If we round off it to 2 decimal places, 1.65. So let's see if they also got 1.65. 1.65. Yes, they got 1.65. Then let's interpret that answer. So is the solution of silver nitrate dilute or concentrated? It is concentrated because its concentration is greater than what? Greater than 1. So it's the concentrated solution of silver what? Nitrate. Why are we saying it's concentrated? It's based on that answer. The concentration of it is greater than what? Greater than 1. All right. So this solution contains large amount of silver nitrate in proportion to the volume of what? Of water. Then these are other examples. Calculate the mass of a substance that must be dissolved to make up 500 cubic centimeters of the following solution. Right. So it's a sodium hydroxide solution with a concentration of 0.6 mole per cubic decimeter. Sodium hydroxide is a strong base, right, which is corrosive. So it's a strong base, but we can dilute it, all right? So if we dilute it, we add water, right? So this is dilute. A solution, or is the dilute solution of what? Of sodium what? Hydroxide. Why am I saying it's dilute? Look at the concentration of it is less than 1. So it's a dilute, a solution of sodium hydroxide. All right, it's the dilute solution of sodium hydroxide, which means that this solution of sodium hydroxide contains small amount of sodium hydroxide in proportion to the volume of what? Of water. So it's dilute because I'm looking at its concentration is less than 1. Right, then first thing that I did here, it was to calculate the molar mass, which is, I think all of us were aware of how to calculate it. So sodium is 23, that is the relative atomic mass of sodium, and then oxygen is 16, and then hydrogen is 1. So 23 plus 16 plus 1 is what? Is 40 grams per mole. Right, then the volume is 500 cubic centimeters. Then remember, the volume should be in cubic decimeters. So we have to divide by what? By 1000. So if you divide 500 by 1000, then we get 0.5 cubic watt decimeters, right? Then from here, we have given the concentration. So from the concentration, we can calculate what? The number of moles. From the equation, C equals to N over V. So from C equals to N over V, then making N the subject of the formula, then from this equation, right? Then N is CV. So what is the concentration? Is 0.6. What is the volume? Is 0.5. Then these are number of moles. Then from the number of moles, convert those number of moles to mass using the equation. N equals to number of mass over molar mass, where M will be number of moles times what? Molar mass, right? So number of moles is 0.3 times 40. Then the mass of sodium hydroxide that must be dissolved, right, to make the concentration, to make a solution of sodium hydroxide with a concentration of 0.6 mole per cubic decimeter should be what? 12 grams. So it's like grade 11s. You will see when it comes to your acids and bases, it's something to do with the standard watt solution, right? So we can say this is a standard watt solution. Why am I saying it's a standard solution? Because if its concentration is known, or is precisely known, the concentration of this solution is 0.6, right? Then we can prepare a standard solution. So if we want to prepare a solution of sodium hydroxide with this concentration, right, how many grams do we need, or how many grams of sodium hydroxide do we need to dissolve in 500 cubic centimeters so that we have this concentration? It's 12 grams, so we can calculate that. Okay, so that is still grade what? Grade 11, right? So I think for today we are done. We have covered, the relationship between the number of moles, mass, molar mass, concentration, number of moles, volume, number of moles, volume of a gas, molar gas volume, right? Number of moles vis-a-vis number of particles, and Avogadro's constant. So we've covered that. I think for today, it's enough of what we did. And let's see next time. Thank you so much for attending this lesson. Thank you.